Now, just because you have a solute which you are dissolving in a solvent does not necessarily mean that you can dissolve unlimited amount of that solute in that solvent. For example, if you take a glass full of water and to that glass full of water you start adding tablespoons of salt. You can add 1 tablespoon of salt, stir it, and it all dissolves. You can add then another tablespoon, it dissolves. Add one more, it dissolves. Perhaps one more, it dissolves. But as you start to add more and more, at some point you will reach a situation where you cannot dissolve any more of that salt in water. And at the given temperature at which you are trying to dissolve that salt in water, you have reached a point known as the saturation point. And the solution you have at that point is called a saturated solution. A saturated solution contains all the solute that can be dissolved at a particular temperature. It will not dissolve any further. There is a way to force it to dissolve more and to make it something called a supersaturated solution. A supersaturated solution contains more solute than can be dissolved at that temperature, at the current temperature, whatever that is. The way it's done is you heat the solvent and you saturate it. Now, generally speaking, when you are trying to dissolve a liquid or a solid in some liquid such as water, so let's say you add salt to liquid water. As the temperature goes up, the amount of solute you can add will increase. And you may have noticed that if you ever like to bake cookies or make something sweet at home and you need to make a syrup solution, you may add sugar to cold water, but it will only dissolve a limited amount of sugar. Then you heat your water, and as the water is being heated on the stove, you can add more sugar and it will dissolve it, and you can keep on doing it until the temperature of water can go up, and the maximum amount of sugar you can dissolve would be as long as you have your water in the liquid state, which is the boiling point of water at which you can dissolve the max sugar. Well, as the temperature went up, the solubility of sugar also went up. And that's generally the case with solids trying to dissolve in water or other liquids trying to dissolve in water. That's not the case with gaseous solutes, as we will soon see. But you can make a supersaturated solution where at a given temperature you have dissolved more of the solute than is allowed at that temperature by first heating up your solvent. And as you heat the solvent, you should technically be able to dissolve more solute, and so you add more solute. And then you slowly cool it. When you cool it very slowly, sometimes the excess which should precipitate out, because now that the temperature is coming down, less solute should dissolve. So technically the solute that should not dissolve any longer should come out and settle at the bottom of your glass or your pan or pot, whatever you are trying to do this in. But if you cool it slowly, sometimes it will not precipitate out, and as long as you don't agitate it or disturb it, what you have is a supersaturated solution. So that's a saturated solution at any given temperature where you can dissolve the max amount of solute, and a supersaturated solution where you have uh, tricked it into dissolving more of the solute by heating the solvent first and then slowly cooling it down. Now, as I said, most liquids and most solids have their solubility go up with temperature, and you can see that in this graph. You can see different kinds of solutes like potassium nitrate, sodium nitrate, sodium bromide, potassium bromide, and so on. Most of them, as the temperature goes up on the x-axis, the solubility in grams per 100 gram of water goes up. So if we look at one of it, for example, potassium nitrate, you can see how potassium nitrate at around -75 degrees dissolves about 150 grams of potassium nitrate in 100 grams of water. Okay, that's a lot. And in this case, although in terms of grams you have more oh, solute than water, ultimately the liquid is going to be water, and the solid which now dissolves is going to be your solute, which is potassium nitrate. And so we still classify potassium nitrate as the solute and water as the solvent. But these lines represent what would be a saturated solution for different kinds of solutes. Some of them, like sodium sulfate and cesium sulfate, actually go down in solubility as temperature is increased, while there are others which barely rise. Sodium chloride solubility does not go up with temperature as much as potassium nitrate or sodium nitrates does.